first thing I want to talk about is solving equations is we have variables. And what a variable is it's a placeholder for an unknown number. It represents the unknown number. So, like you're standing in line and you tell somebody, hold my place in line, and then you leave for a while. They are representing you, so they're kind of like your variable. They're holding your place in line. But for a variable, they have a value that they are representing, and it changes. That's why they're called variable, because variable means to change. And so x in this equation could be 2, x in another equation is negative 73, x over here is a half. It can be any number, so it changes. That's why they're called variables. And so solving equations is really solving a puzzle. And we're trying to find the mystery identity of that variable. Who is x trying to be? Equations, especially single-step equations, is basically exactly like we're doing here. What number can I add to 2 to get a 5? 3. Okay, what number can I subtract 6 from, and I'll get 10? 16. If I divide a number by 2 and I get 5, what number was it? 10. If I take a number and I multiply it by 3 and I get 12? And if I take a number and I add 6 to it and it gives me negative 4? Negative 10. Okay, basically what you guys just did is I took equations and put them in word format. You just solved single-step equations. This sentence here is actually x plus 2 equals 5. This sentence here would actually be x minus 6 equals 10. Here, x divided by 2 equals 5. 3 times x equals 12. X plus 6 equals negative 4. Okay? So you were able to rationally, in your head, come up with these numbers. You can do the same thing with a single-step equation. What number that we add 2 to equals 5? Well, we do a step to solve that. But algebra is dedicated to solving equations. That's pretty much most of algebra. Solving equations. Find x. You guys have seen that? Sure. Quit asking where your x is. Nobody cares. Have you guys seen that? Algebra, we don't care where your x went. Yes, that's the one. Okay. That's algebra. We're always trying to find x. Or any other letter, really. But an equation is a mathematical sentence. A sentence. But written in math. So with symbols, symbolic words. Containing an equal sign that states two expressions represent the same value. X plus 2 is equal to 5. So x plus 2 and 5 are the same. And it doesn't matter what's on either side. They have the same value. Okay, so what we're going to do is we're going to find the number represented by the variable. So this is accomplished by performing operations. So we're doing single-step equations right now. So we're only going to do it on one side of the equal sign. No, sorry, not performing operations. Isolating the variable. Forgetting what I wanted to say. Okay, on one side of the equal sign. So to do that, we move numbers away from the variable. And to move numbers away from the variable, we do the opposite of what was already done. We're undoing. Okay, so to solve an equation is to undo what they did. Okay, so addition and subtraction are opposite. And multiplication and division are opposite. Okay, so if they added, we subtract. If they subtracted, we add. If they multiplied, we divide. If they divided, we multiply. We're always going to do the opposite of whatever they did, and by they, I mean whoever wrote the problem. Sometimes that's me, sometimes that's a book publisher, whatever. Equations. We're going to start with a single step where we add. X minus 7 equals 12, so we're going to add 7 to both sides. The reason we do that is because negative 7 and 7 will cancel each other out. I'm left with x. X equals 19. Okay. Y minus 13 equals negative 5. They subtracted, so I add. Those cancel each other out. I'm left with a y on this side. Negative 5 plus 13 is 8. Right, I owed you $5. I had 13. I gave you your 5, and I have 8 left. Okay. Y minus 6. I'm going to add 6 to both sides. Again, because those cancel. Y equals 24. X minus 2 equals negative 2. Well, if I add 2 to both sides, those cancel and those cancel. 0. Okay. So basically, when I say these cancel, what this becomes when I add 13 to it is y plus 0 equals 8, but the plus 0 we don't care about. So it just goes away. So if you're canceling on numbers, you can't just say x equals and then nothing. You have to put the 0 there. All right. Next step, we're going to solve by subtracting. They added, so we subtract from both sides. For the same reason, those will cancel. X equals negative 4. If I subtract 4 from both sides, y equals negative 10. I would like you all look at any time you see a number attached to a letter with nothing in between them, this is multiplication. So this is 3 times x. Okay. So if they're multiplying, we're going to divide. So I'm going to divide both sides by 3, and I'm going to get x equals 6. Divide both sides by 5. X equals negative 4. Divide both sides by negative 6. Okay, bring the negative with if it's a negative number attached. X equals negative 3. Divide both sides by negative 2. X equals 5. Now, I forgot to write this on here, but sometimes you'll get something like this. Negative x equals 7. This is technically negative 1x equals 7. So this is what that means. And so technically speaking, on the technical side, I would be dividing both sides by negative 1 to get x equals negative 7. However, if you see this where you have a negative x, you can just change both signs. You don't have to actually show dividing by negative 1. You can just change both signs and you're okay. Make sense? Okay, what if they don't divide evenly? 4x equals 17. I divide by 4. I divide by 4. 17 doesn't divide by 4. Okay. X equals 17 fourths. Okay. Divide by 3. Divide by 3. 11 doesn't divide by 3. Okay. X equals negative 11 thirds. The only time you have to do something different is if I have 6 and 6. X equals 9 sixths. But both 9 and 6 divide by 3. So I'm going to reduce the fraction. So I'm actually going to have 3 halves. But you don't have to give me a decimal answer or do the division. You can just leave it as an improper fraction. Improper fractions are totally cool. Likewise, if you have 15x equals 5 and you divide both sides by 15, 5 does not divide by 15. So it would be a fraction. In this case, they both divide by 5 though, so I would reduce it to get x equals 1/3. Or here, where I divide by 12, x equals, it would be -8/12, but both of these divide by 4. So I get -2/3. And if I have something like 6x equals 7, not 17, sorry. Wrong arrow. Let's do 17x equals 6. And I divide both sides by 17, I just write the fraction. Okay, so don't let the fractional answer freak you out. Improper fractions are fine. Proper fractions are just great. We like fractions in algebra. This equals x divided by 7. This is not a fraction. This is division. Okay? It's kind of both. It's x sevenths, but it's also x divided by 7. Fractions are division. So whenever you see this now, I want you to go, this is x divided by 5, x divided by 4. I don't want you to think of it as a fraction. I want you to think of it as division. So if x is being divided by 5, the opposite of division is multiplication. Those will cancel. X is left. -13 times 5 is -65. X divided by 4, the opposite of divided by 4 is to multiply by 4. Those will cancel, and I get x is equal to 20. If I have a negative out front, like this, multiply both sides by -3, because that takes care of the negative and the 3 at the same time. And I get x is equal to -30. Questions on those at all? Okay, 32 divided by x equals 8. They don't teach you this trick, but there's a trick. If you have the variable by itself, it has to be by itself in the denominator, equal to a number by itself, you can trade those places. And this becomes 32 divided by 8 equals x. And the reason that works, I'll show you really quickly. You don't have to write this down. I would multiply both sides by x, right? And so I'd get 32 is equal to 8x. And then I would divide both sides by 8 to get 32 divided by 8 equals x. So all that happened is the 8 and the x switched places. So you don't have to do all that. You can just, if this is by itself and this x is by itself, or y or whatever letter, you can just trade places to get x equals 4. Or you could write 4 equals x. It doesn't matter. Yeah.
What if x wasn't in the fraction? It was like 3/5 x.
Those will be next. We'll come up with those. Here I've got 5 over -20 is equal to x. So that's going to be -1/4 because I divide both of these by 5 to reduce the fraction. And then here I get x and 4 changing places. So I have -28 over -4 equals x. So x is equal to +7. Okay. When you take a two-step equation, it's the same as a one-step equation, except we have to do 2. We're still doing the opposite operation. So if they add, we subtract. If they subtract, we add. If they multiply, we divide. If they divide, we multiply. But you do the addition and subtraction first. then the multiplication and division. Okay, order of operations tells us we multiply before we add, right? So if we're undoing what has been done, we have to go backwards. So if you normally, with real numbers, multiply and then add, if you're solving an equation, you go backwards, so you subtract and then divide. Does that make sense? Okay, here. They multiplied and then subtracted. If we were doing order of operations, if there was a number here, we would have to do the 5 times whatever that number was first and then subtract the 3. So if we're undoing it, step 1 is going to be to add or subtract. So I'm undoing this, so they subtracted, so I'm going to add. Okay, and then step 2 is to multiply or divide. They multiplied, so I'm going to divide. Good? Okay, they added, so I'm going to subtract. Okay, and that's a negative and a negative, so I add the numbers together to get the negative 30. They multiplied, so I'm going to divide. Okay, here they added, so I'm going to subtract. And then they divided, so I'm going to multiply. Okay, and again, here they added, so I'm going to subtract. Now, if this negative is out front, we're going to, again, multiply by -9 to take care of the negative at the same time. Because they divided, so I'm multiplying, so I get -81. And some people consider them to be two-step equations. And I'm going to show you both ways. And the reason I'm going to show you both ways is because I don't care which way you do it. You pick the one that makes the most sense for you. Okay? So as you can see, here are the same exact equations. If I am going to solve them in one step, I'm going to multiply both sides by the reciprocal. Okay, the reason I do that is because these cancel each other out. And I'm left with x. And then 3 goes into 12 4 times. And so I multiply 4 times 5, so I've got -20. So what I did here is I multiplied by the reciprocal. It's one step. Okay. If you don't like fractions and you don't want to multiply fractions because you think fractions are icky, you can do this in 2 steps. Step 1 is to multiply both sides by the denominator. Okay, so I'm going to multiply this by 5, and I'm going to multiply this by 5, and those 5s are going to cancel out, and I'm left with 3x. And I get 3x equals -60. And then step 2 is going to be to divide both sides by the numerator. Divide by 3, divide by 3, x equals -20. Same answer, one step, 2 steps. Here I multiplied and then divided. Here I just multiplied. It's a matter of preference. Do you like to make things shorter so you don't have to write as much and you don't mind multiplying by fractions? Then you can multiply by the reciprocal. Do you hate dealing with fractions and it's confusing? Well, then you multiply by the denominator and then you divide by the numerator. And here you can see if the 5s are canceling out, the 3 and the x are all that's left. So we'll do 2 more. I'm going to multiply by the reciprocal. These will cancel each other out. 2 goes into 6 3 times. 3 times 3 is 9. And so I get x equals 9. Or again, if you hate fractions, multiply by the denominator. The 3's cancel. I'm left with 2x equals 18. Divide by 2. X equals 9. Both are valid. Both will give you the same answer provided you do them correctly. And I don't care which one you do. Pick the one that makes the most sense for you. Typically considered two-step equations, but we can answer them in 2 or 3 steps. Again, because with the fraction reciprocal thing, I can add 10 to both sides, and I get 3/7 x equals 6. And then if it's a fraction reciprocal thing, I multiply both sides by the reciprocal. And x is equal to, let's see, 3 goes into 6 twice, so 14. Or you can do this in 3 steps. If you hate fractions, which some people do, no judgment. I'm going to multiply both sides by 6, or 7, sorry, 7. So I get 3x is equal to 42, and then I will divide both sides by 3 and get x equals 14. So in 2 steps, you're going to add or subtract, then multiply by reciprocal. In 3 steps, you're going to add or subtract, multiply by the denominator, and then divide by the numerator. So that's 1, 2, 3, or 1, 2. All right. Part of the thing that will help you in word problems is to know what operations certain words mean, because basically we're translating words into math. This is not by any means a 100% complete list, but this is a pretty, intense list that has a lot of them.
How many what'd you say how many feet you want to write out now?
5,280. So, keywords are the words that mean addition, mean subtraction, mean multiplication, or mean division. So, for addition, you get things like plus, sum, total, added to, in all, more than, gain of, additional, altogether, combined, how many altogether, how many in all, how many, just how many, how much, increase of or increased by. These all mean addition. Okay. Subtraction, you have minus, difference, change, taken from or take away, have left, less than, loss of, remaining, save, dropped, how many left, how many remain, how much less, decrease of, decreased by, how much more or how much less. Now, minus, if you say a number minus 10, this like minus 10, so x minus 10. If you say this is a number minus 10, but if you say less than, 10 less than a number, if you say something less than, the thing that's in front actually comes after the minus sign. If I have $5 less than you, you would take however much money you have and subtract 5, and that would tell you how much money I had, right? So just be careful of the order with subtraction. You have to kind of logic that out sometimes. Multiplication, product, times, and of. This is the one that people don't typically know. Of means to multiply. Most often it's used with fractions, decimals, and percents, but of means to multiply. And then twice is times 2, triple is times 3, double forgot to put that on there, sorry. Double is times 2. Okay, and then division, you have quotient goes into per, half is to divide by 2, third is to divide by 3, divided by or evenly. Evenly means to divide things into even groups. For this, I want you to translate a sentence into an equation and then solve it. So 5 less than 1/2 of a number is 2. So we're going to break this into pieces. Okay, 5 less than. That's going to be minus 5. Because it's 5 less than, so I'm subtracting 5 from it. And then I have 1/2 of a number. So 1/2 times x, y, z, whatever letter you want to use. A number is just your variable. Is means equals. And 2 means 2. Okay, so 5 less than 1/2 of a number is 2. Well, this is out of order, right? So I'm going to rearrange it to make it make sense. I'm going to do 1/2 of x minus 5 equals 2. And then I'm going to solve it. So to solve it, I'll add 5 to both sides. And I hate to do that, but I guess I didn't give myself enough space. So I get 1/2 of x equals 7. To get rid of a half, I'm dividing by 2. A half is to divide by 2, so I'm going to multiply by 2. X equals 14. Okay. 3 less than minus 3. 2/5 of a number. 2/5 x. And then is 7 would just be equals 7. Again, this is out of order, so I'm going to rearrange it so that it makes sense. I'm going to add 3 to both sides. I'm going to move over here and I get 2/5 x equals 10. Now, I can either do this in 2 steps or 1 step. I'm just going to use 2 for right now. So I'm going to multiply by the denominator, which will give me 2x equals 50, which I'm going to rewrite up here. And then I'm going to divide by the 2 to get x equals 25. Now, 8 more than 2/3. Okay, 8 more than is 8 plus. So I don't have to do plus 8. I can do 8 plus. 2/3 of a number is 20. And I can either put the 2/3 x in front or I can leave it where it is because addition is commutative, so that means it doesn't matter what order I put it in. So I'm just going to leave it out front. Steps are still going to be the same though. I'm going to subtract 8 from both sides. And I'm going to be left with 2/3 x equals 12, right? No, that's a bad place to put the arrow. Do you want me to multiply by the reciprocal or do you do the 2 steps? Do the reciprocal? Okay. Why are you doing that? Times 3 halves. These will cancel each other out. 2 goes into 12 6 times, and then I do 6 times 3 to get x equals 18. Got the word odd in there. Okay, consecutive integers. Okay, you can have consecutive integers. You can have consecutive even. And you can have consecutive odd. Consecutive means in order. So if I pick any number 7 to start with, consecutive integers starting at 7 would be 7, 8, 9, 10, forever and ever and ever. Consecutive consecutive even integers, if I pick any number 4, it has to be even because I said even. 4, 6, 8, 10, etc. And then consecutive odd is going to be, say I pick 11, 11, 13, 15, 17, etc. When you're doing consecutive integer problems, we have to set up algebra. If I say my first number is x, to get from 7 to 8, what did I do? I added 1. And then to get from 8 to 9, I added 1 more. So each time I do x plus 1, x plus 2, x plus 3, x plus 4, x plus 5 to get those numbers. This would be 7, 8, 9, 10. If I'm doing even numbers, and 4 is x, what did I add to 4 to get to 6? And then I added 2 more, and then 2 more, etc., etc. So this is 4, this is 6, this is 8, this is 10. And if I started at 11, how many do I add to get to 13? 2. So both the consecutive odd and the consecutive even will use x, x plus 2, x plus 4, etc. Consecutive integers is x, x plus 1, x plus 2, x plus 3. So if I find 3 consecutive integers, I need to take 3 of those whose sum is 72. So I'm going to take 3 of those and I'm going to add them together. So x, x plus 1, and x plus 2. Those are my 3 integers. And I'm going to add them together. And I get 3x plus 3. 3 integers, 3x plus 3. If I did 2 integers, though, it would only be 2x plus 1. Equals 72. Subtract 3 from both sides. I get 3x equals 69. Divide by 3. X equals 23. So that's my first one. My second one is 24, and my next one is 25. So these are my 3 integers, 23, 24, and 25. X is just the first one. Okay, if I do even or odds, I'm going to do the same thing. I need 3 of them, so I'm going to use x, x plus 2, and x plus 4. And my sum, so I'm adding, is 42. So I'm going to add these together. And I'm going to get 3x plus 6. Sorry, they both equal 42. I'm going to subtract 6. And I'm going to get 3x is equal to 39. 30, not 39. What am I doing? Guys, catch my subtraction errors. 36. Divide by 3. And x equals 12. This time I wanted even integers, so my first one is 12, 14, 16. Now, if you want, you can check yourself. I can add them together and prove to myself that it's true. So 23 plus 24 plus 25 equaled 72, so I'm right. 12 plus 14 plus 16 equals 42. So I know I'm right. Consecutive odd integers are going to use the same x plus 2 and x plus 4. So I'm going to add those together.
Why is that?
Because both even and odds, to get from 11 to 13, I add 2. To get to 13 to 15, I add 2 more. So you're adding 2 because you're skipping 1. Does that make sense? Okay. And that's 117. So I get 3x plus 6 is equal to 117. I'm going to subtract 6 from both sides. And I get 3x is equal to 111. Now I know that 111 divides by 3 because if I add 1 plus 1 plus 1, it equals 3. And if the sum equals divisible by 3, then the whole thing is divisible by 3. But I don't know off the top of my head what 111 divided by 3 is, and I could work it out, but I'm going to cheat. 37. So x equals 37. So my 3 odd integers are 37, 39, and 41. And again, I can check that and make sure I got it right by just adding them together. Okay.